Yes.
Okay.
Okay. Can you see my screen?
Yes, we can.
Yes. So I am glad to take part in this symposium. My name is Andrei Pavluk. I'm one of the author of this investigation. The topic of our research is innovative method of determining deflection of wooden beams on the basis of moment-curvature diagram. Wooden elements are most often used as load bending elements in the form of beams. Different loads act on such elements. These elements are reliable and durable, subjected to normal operating conditions. In order to ensure the normal operation of wooden beams, it is necessary to determine the limit values of the load-bearing capacity and the possible limit deflection of such elements. This will ensure the reliability of the structure. The purpose of the work is to develop a method for determining deflection of wooden beams based on moment curvature diagram, taking into account the non-linearity of the deformation of wood as a material. To determine the limit deflection of the beam, we will use the normative value of the current normative document DBE. This is Ukrainian building standard, and Eurocode 5, namely the ratio of the deflection to the span for a different kind of building construction. You can see on this slide this limit deflection. In next slide, we can see calculation sequence. First step is find the external graph of moment that act along the length of the beam using the basic principles of material resistance depending on the maximum moments MF, MFK, MQ, MQK. Determine the curvature of the element based on the moment curvature diagram depending on the maximum moment MF, MFK, MQ, MQK. According to the same principle, you can determine the curvature along the entire length of the beam and build its graph. Next step is find the rotation of the beam. The first option is the method of finite elements. The second is the integration of the curvature change function along the length of the beam. Determine the deviation of the beam from the initial position in the same way. The both variants make it possible to obtain a value of rotation angle of the beam regarding in the initial position. In our opinion, the second variant is simple, so we will consider in this work. If you divide the wooden bending elements into equal parts and determine curvature at the edges of these intervals, you can determine the average curvature over the entire section. Suppose that we have that section of the bending elements in which the curvature occurs at each point along its length. The rotation angle of two edges of this section of wooden beam will be equal formula number 1, where alpha is the angle of rotation in the section of bending wooden elements, L is the length of the beam section, and R is the radius of rotation of the beam. It is known that the curvature for such section of wooden beams will be the inverse, the radius, namely C. Formula number 2. The rotation angle of the end section starting from the beam center can be determined by the formula number 4, where alpha n is the rotation angle at end section and n the number of beam section, alpha 0 the initial rotation angle, 0 angle. With the variant of differentiation along the length of the beam, we will obtain that the elementary rotation angle of the bending elements is equal to its elementary length multiplied by the curvature that acts on this elementary section. Formula number 5. Follows that the angle of rotation in the section of the bending element that accumulates in the beam is equal to the integral expression, formula number 6. In order to determine a deflection of bending elements, initial condition must be set the position of the natural axis or the initial rotation angles are used initial data for a beam with symmetrical loading. Thus, determining beam deflection will include determination of beam's rotation angle as well as determination of deflection in each section of this beam. The deflection of the beam with symmetrical load will be equal to the sum of all deflections of section with constant curvature, as well as the initial deflection of the point from which the deflection is determined. Formula number 7. And deflection for the section can be determined using formula number 8 and 9. At the same time, deflection should be determined from the point where the value of the initial angle of rotation alpha 0 of the beam is known. Several points of the operation of wooden beams with different loading option were simulated. A beam on 2 supports with concentrated load, a cantilever beam, beam with poor bending zone. In slides we can see this scheme. In next slide we can see graph. Graph of this slide shows the dependence of the width of the cross section and length of the beam on height using the maximum bending moment that the cross section can absorb and deflection. The first graph is constructed for bending elements on 2 supports with applied uniformly distributed load. The second is for effort with a point applied load. The graph divides the beam into 2 zones upon reaching the limit state of the element. If the geometric characteristic of the bending element fall under the line of depicted graph, the element will reach the limited state under the limited load. Otherwise, the maximum deflection will be reached. It can also be concluded that the most effective section will lie within the width from 0.2 to 0.4 of the height of the section and the length from 10 to 11 of the height. Graph of the dependence of the ratio of geometric dimension at the coincidence of 2 limited states, limit, deflection, and failure. Taking into account the fact that non-glued wooden elements are designed with limited cross-section, height, and length, in such element, the limited state of deflection occurs earlier than the limited stress. And conclusion. A new technique for determining deflections that takes into account the non-linearity of wood deformation has been developed. Deflection diagram for wooden beams under different types of load and different types of fixing are determined. It was established that the shape of the curves and deflection graphs is significantly different from the graph currently used to calculate deflection, and the dependence of the simultaneous achievement of the limit states of the first group, its mean bearing capacity, and the second group deflection of the ratio of the geometric dimension of wooden beams was established. That's all. Thank you for your attention.